Today we are going to start section 6.2, talking about properties of parallelograms. So we are going to be using those properties, becoming familiar with what a parallelogram is, and all of its special characteristics. After this lesson, moving forward, we will start talking about specific types of quadrilaterals, some of which will be parallelograms. All right, some of these warm-ups ought to look familiar. We'll start with the first two. Given that angle P is a supplement of angle R and the measure of angle P is 164 degrees, find the measure of angle R. Who remembers what the word supplement means? Jaden? Those two angles add up to 180. So supplement should make us think that they add up to 180 degrees. So if they give us one of the angles, how can we find the other one? Jaden? Subtract. 180 minus 164 would give us? What is it? 16. So angle R would measure 16 degrees. All right, on number 2, we are asked to find the value of x. What is true about the two angles here? Okay, together they would equal 180. They are what we would refer to as a linear pair, which means they are supplementary. They add up to 180. So we can take 2x plus 117 plus x, and all together that should equal 180. Next thing we need to do, combine like terms. 2x plus x. So we have 3x plus 117 equals 180. Next thing, subtract the 117, 3x equals 63. I'm running myself out of space. 3x equals 63, last step. Divide by 3, x equals 21. All right, at the bottom, we've got 3 polygons. They are all what type of polygon? Quadrilaterals, which means all the angles on the inside should add up to 360. Okay? So if we're just finding the missing angle, we're just trying to find angle A. We know they all add up to 360. How can I find the missing one? Subtract. Subtract all the other ones off from 360. 360 minus 100 minus 95 minus 85. What do we get for angle A? 80? It should be 80. I would agree with 80. Oops, sorry, I wrote it on the wrong one. 80. There we go. All right, what about on number 4? It's the same type of problem. Do we agree with 108? I think we should. I think 108 sounds good. What do we have to remember that those boxes mean? Those are both 90 degrees. Do we have questions on 3 or 4? Those ones are a little bit easier. Martez? It's a great question. So to do number 5, I'm going to take away 3 and 4 so that I've got a little space. On number 5, we know that all those angles add up to what?
Oh, wait. Me. 360.
360. So those angles would be x and x and x and 165. So I add them all up. I should get 360. What's the next thing we do? Combine like terms. X plus x plus x gives us 3x. You got to use all those x's. After we use all those x's, now it's back to algebra 1. What are we going to do? Subtract 165. We get 3x equals... What is it?
195.
195. Okay, last step.
Divide by 3.
Divide by 3 and x equals...
65 degrees.
Well, x is not... Well, okay, x would just equal 65. But yes, those angles would each measure 65 degrees. All right, today we are going to talk about parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So it's a pretty descriptive name. A parallelogram has both pairs of opposite sides parallel. Okay, before we get to the theorems, I think we've got what the symbol is, right?
Yeah, right.
So the symbol for a parallelogram just looks like a slanty sort of rectangle. So it's like a slanted rectangle. It's like a little parallelogram itself. Something like that. Okay, so it should look like the other sides, the opposite sides are parallel to each other. It won't usually be marked like this. Okay, but those should be parallel. Opposite sides would be parallel. Okay. Do your best. I don't expect you to be an artist. You can draw a slanty little rectangle. I believe in you. All right. Let's get on to those theorems. First one. If a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So from the definition, we know that opposite sides are parallel. Now we know opposite sides are congruent. Opposite angles are congruent. Next one, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. That means angles that are right next to each other add up to what? 180. So if you want to put a little note after supplementary that says 180 degrees, it's a little reminder you can do that. Consecutive angles are supplementary. You'll be all right. Ready for the fourth one? Get ready. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Its diagonals bisect each other. So the diagonals we talked about yesterday, they connect non-consecutive vertices. In a parallelogram, that means they cross through the middle of the parallelogram. So here's where we've got some pictures where we will show these properties. So if you want to draw 3 or 4 little parallelograms off to the sides, I'm going to do the first 2 in the same parallelogram. Opposite sides are congruent, opposite angles are congruent. So my top and my bottom sides, I'm just marking with 1 little tick mark. The left and right sides, I'm marking with 2 little tick marks. Opposite sides are congruent. That's number 1. Number 2, I'm going to put in the same diagram. Number 2 says opposite angles are congruent. So this top left angle is going to be congruent to the one opposite it or across from it, which would be the bottom right. So they each get 1 arc mark. Then the other 2 that are left, the bottom left corner and the top right corner, are also congruent to each other, so I'm giving them each 2 arc marks. All right, number 3, going in the second diagram at the bottom here, is that consecutive angles are supplementary. That is a little bit harder to depict. Okay, but I am going to label them A, B, C, and D. Those are my angles. So for consecutive angles to be supplementary, if I were to add angle A plus angle B, it should add up to what? 180. If you add any 2 angles that are next to each other, then those angles should add up to 180. So you could do the same thing with angle B plus angle C. Those would add up to 180. And you can keep going around the parallelogram. Any 2 angles right next to each other should add up to 180. You don't have to write all of them out if you get the idea here. 2 angles next to each other should add up to 180. Last pair would be angles D and A. Okay, so we can show that 2 angles next to each other add up to 180. Questions about number 3? Okay, number 4, I'm going to continue to use this middle one since on the board that last one's kind of covered up with the logo. So I'm going to leave it as being labeled A, B, C, D, but this time I'm going to add those diagonals into my parallelogram as best I can. And I'm going to mark the point in the middle where those diagonals meet as point E. This is number 4. No, this is no longer considered trigonometry. That was last chapter. We are back to just good old geometry. If the diagonals bisect each other, then that means that segment BE is going to be congruent to which other segment? ED. That also means that segment AE is going to be congruent to which segment? EC. Okay, you could mark that in the diagram if you prefer to use little tick marks instead. We can mark it in the diagram. But we have to remember that bisect means that it gets cut in half or split into 2 congruent pieces. The diagonals are bisecting each other, so both of the diagonals are getting cut in half. All right, our first 2 examples, we've got parallelograms KLMN. We are told in the directions that it is a parallelogram. So that means the definition of a parallelogram is true, and any of those theorems that we just talked about are true. If you know it's a parallelogram, you can apply any of those theorems. So they are asking us to find the measures of MN and KN. On our first parallelogram, MN, down here at the bottom, what would its measure be? Don't make it harder than it is. It's 15, because what's true about the opposite sides of parallelograms? They're congruent. So that means that KN is going to have a measure of 6. If you know it's a parallelogram, you know opposite sides are congruent. So on letter B, MN has a measure of 8.
12.
And KN has a measure of 12. So on number 2, when we are asked to find the missing angle measures, that means all of them. That doesn't just mean one of them or 2 of them. We should be able to fill in all the missing angles. So for letter A, what's going to be the easiest one to fill in right away? T. T should equal how many degrees?
75.
Why? Opposite angles are congruent. So we should be able to fill in the opposite angle right away. It's going to be the same. But then we've got those other 2. We know the other 2 should be the same, but we don't know what they are yet. The last 2 are not both 75. What do we know about 2 angles that are right next to each other? They equal 180. 2 angles right next to each other should equal 180. So I've already heard some people say that those missing ones should then be 105. Questions about how we got those angles? 180 minus 75. 2 angles that are right next to each other should be supplementary. All right, finally on 2B, which angle can we fill in right away? V is 130 degrees. How are the other 250? Good. 180 minus 130 would leave us with 50. Make sure when you have questions like this that you fill in all of the angles. Last year on tests and quizzes, I had a lot of students that would just fill in one other angle. Like they would just fill in a 105. And assume like, well, you know that they're congruent. Yes, I know that. I need you to show me that you know that. Okay, so if you don't fill them all in, if this question was worth 3 points and you only fill one of them in, you're getting 2 points off. Are we clear on that? But ask for the measures, you got to find all of them. All right, on the number 3 examples, we have parallelograms JKLM. This time we are asked to find the length of JN. Okay, so JN comes out of this corner and stops in the middle. It is part of a diagonal. Why is JN 3 for this first example? What's true about the diagonals from our theorems? They bisect each other, which means they split each other in half. So if NL has a measure of 3, JN has to have the same measure. They're both 3. What about on letter B? It would be 8. If we have this split in half, that means both pieces would have to have a measure of 8. That is it.